This is part 3 of videos on endogeneity and two-stage least squares. We're getting towards the end and we're looking at a real example. This is a very famous example. Looking at wages, education, and endogeneity. And so the idea here is that people are forward-looking and pick how much education they want, anticipating that the more education that they have, the higher their wages will be, right? And when you have that forward-looking behavior like that, you get endogeneity, and then the impact of education on wages will be biased. You will misestimate that. And so the common wisdom is the more education, the better the job, the more money one makes. I believe that. I've been in education for a long time, as long as you don't get a PhD. But endogeneity is a problem with it, you know. We might be overestimating the impact of education or underestimating it. And usually with this kind of data, ability is not observed. Okay, so one of the issues are for economists who work in education is you cannot randomly assign people to different education outcomes, right? You can't say, hey, you people here, randomly sample people and assign them to only have like a grade school education, take other people, random sample, and assign them to high school, take another sample, random sample, assign them to a college education, and so on. You can't do that. You just have data. People went to school. Okay, you could say, hey, smart people go to better schools, something like that. Smart people also make more money. So what's the true impact of education on wages, right? Okay, so we don't have that random sample. We didn't do an experiment where we could assign people to different outcomes. Very famous data set, the CARD data set from 1995. And what's unique about this data set, it has an IQ score. I don't want to get bogged down in debates about IQ. Let's just say that this is a test of cognitive ability of some kind. It's been shown to be reasonably correlated with performance in school and some relationship with wages. So our focal variable will be log wages, and our predictors are years of education, the IQ score, age, whether or not the person lived near a four-year college or not. The parents' education matters, some other variables like geographical location, and so on. Okay, so just taking a look at the correlations, you see wages have a kind of a mild, not very strong, kind of like wishy-washy correlation with education, age, and less so with IQ. Okay, but then when we look at IQ and education, it has a correlation, right? IQ, one way of looking at it is, IQ measures how well you learn to do complex tasks. Okay, doesn't say that you can do the task well, it just says how quickly can you learn it. And people with higher IQ tend to do better in school, and they tend to get more education. So education is just a measure of how much education the person has. Now, what we typically do is we don't have the IQ or the ability variable lurking around. We just have like education and age. Okay, and we're going to see what happens with and without the IQ. So take log wage and fit models with and without IQ. You have education and age. You put IQ in, you get a different model. All right. So IQ is important. You typically don't have it, and you see that the impact of education goes down. So once you adjust for IQ or ability, the impact of education on wages is smaller. Okay. Now what typically happens is we don't know the IQ score, so let's just go ahead and ignore it and go through two-stage least squares. And so the first stage is the DV is education, and I have a model for that. Okay, and so I have some instrumental variables that I'm going to use for education that I'm not going to use for wages. Like, do you live next to a four-year school? If your father has more education, you will tend to have more education. If your mother has more education, you will tend to have more education. If you have a step parent, you tend to have less education, okay? And the geographical area matters, okay? So this is a measure of social and economic area that you live in. And there you go. Those are the instruments. We save the residuals and the predicted value. We can do the test for endogeneity. We can do the Hausman test. So we have age, education, and the residuals in it. The residuals have a significant coefficient, which means we do have endogeneity. Okay, so we have to do stage 2 for the endogeneity correction. So we take our predicted value for education. Based on the model, this is what I predict your education will be like. So I don't use your actual education. By doing that, I'm kind of washing away that correlation with the error term. And so I put the age in it. The older you are, the higher the wage. And I put predicted education in. Okay? And step education. All right. So just comparing the two, this is ordinary least squares with just education. And then over here, it's two-stage least squares, right? So I put the predicted education in. And this was a surprising result to the education economist because the value of education actually goes up when you do the endogeneity correction. Okay, the economist would have predicted that the impact of education should have gone down, right? Because if you're doing forward-looking behavior and you're saying, hey, the more education I get, the more higher my wages will be, so I'm going to get more education. If you have that kind of belief about the world, then when you do the endogeneity correction, the predicted education should have gone down. But it actually goes up in this case. And this created quite a stir, and there was a lot of articles. And, even using different data sets and different methods and different techniques, it's been pretty consistent that the actual education, the unbiased education is higher than what you just see in the raw data, which is good for me, right? Because being in education, that says, hey, we're even more valuable than what we thought we were. Okay, but that's kind of cool. Okay, anyway, that's it. Endogeneity occurs in regression when the predictor variables, your x variables, what you're trying to use to predict your y, are correlated with the random shocks. This happens a lot with economic data, okay? And when it does happen, you can use two-stage least squares to do a correction. There's other methods too, but this one's easy and it works, right? You don't need special software. You can do it in Excel if you wanted it to. And, it's a very important topic if you're an economist doing public policy matters. Maybe not so important if you're doing business analytics, data science, and just trying to do some pricing for pricing for a brand. But you got to be aware. If you don't know about it, you may not test for it. If you don't test for it, you can't correct it, and then you're just flying blind. Okay. Hey, thanks very much for sticking with it. If you got something out of the videos, please hit the like button, and I hope to see you in other videos. Happy business analysis. Talk to you later.